In our last video, we saw how to form complex molecular propositions by taking small atomic propositions and joining them with connectives. We looked at the connectives and, or, and not. In this video, we'll look at another connective that is a little more complicated but very important. Everywhere we turn, we run into situations that connect conditions in a cause and effect way. Legal systems are built on these kinds of situations. If you drive faster than 55 miles per hour, you will get a speeding ticket. Or if you steal money, you will go to jail. It's not just in the law that you see these. In your course syllabus, you might see statements like, if you miss a deadline, you must ask for an extension. And we make promises to each other all the time. For example, I might tell my kids, if you clean your room, then we'll get ice cream. All of these statements have things in common. They are made up of two conditions, and if the first condition is met, then we expect the second condition to also be met. If the first condition is met but the second one isn't, then we consider the entire statement to be faulty, like a broken promise or an unenforced law. The connection between the conditions isn't through a single word like the and or constructions from the last video, but through if-then, although we don't always write the word then. This if-then construction is another connective, in other words, that joins two propositions into a larger one. We call these if-then statements conditional statements, because if a condition is met, then an action is supposed to be performed. Conditional statements are everywhere in life and in computer science, so we're going to take a very close look at these. First, in a conditional statement, the condition to be met, usually preceded by if, is called the hypothesis, and the statement that follows, often preceded by then, is called the conclusion. Here you can see the hypotheses and conclusions for each of the examples we mentioned earlier. A conditional statement is a proposition, meaning that it's a complete thought that has a definite and knowable truth value. So how do we know when a conditional statement is true? This takes some thought, so let's use a simple English example, the promise to my kids of, if you clean your room, then we'll get ice cream. It's helpful to think about when the statement is not true. A false conditional statement is like a broken promise. My promise to my kid is false in the situation where they do clean their room, but we do not get ice cream. Because in a conditional statement, anytime the condition is satisfied, the action must follow. If that ever doesn't happen, then we say the conditional statement is false. Obviously, my promise to the kids is good in the situation where they do clean their rooms and then we do go get ice cream. What happens if they don't clean their rooms? Well, my promise says nothing about what we will do if they don't clean their rooms. If they don't clean their rooms and we don't get ice cream, then I haven't broken my promise. But if they don't clean their rooms and we do go get ice cream anyway, I still haven't broken my promise. Again, my promise only said what will happen if they do clean their rooms. If they don't, my promise, as stated, lets me do whatever I want. All conditional statements obey the same rules of truth. Cleaning rooms and getting ice cream are just details. In any conditional statement, say if P, then Q, and by the way, the symbol for this is an arrow that points from the hypothesis to the conclusion, the truth table would look like this. First of all, if both the hypothesis and conclusion are true, then the conditional statement is true. If my kids clean their room and we get ice cream, I've kept my promise. If you speed and then you get a ticket, the law has been enforced properly. And if the hypothesis is true but the conclusion is false, then the conditional statement is false. If the kids clean their room but I back out of getting ice cream, I have not kept my promise. If you speed but do not get a ticket, the law has not been enforced properly. Now, if the hypothesis is false, then if the conclusion is true or if the conclusion is false, the conditional statement is still true. If my kids don't clean their rooms, I'm not breaking my promise if I get them ice cream anyway, and I'm also not breaking the promise if I don't. So this is what the completed truth table for a conditional statement looks like. Conditional statements, in other words, are always true except in this one situation where the condition is met, but the action doesn't follow. So in this video, we learned a new connective, the if-then construction, which makes a conditional statement. You learn that the condition is called the hypothesis, and the action that follows is the conclusion. You also learn the truth table for a conditional statement, and that conditional statements are always true, except when the conclusion does not follow from the hypothesis. In the next video, we're going to look at some more conditional statements, particularly at variations on the basic if-then construction.